Hello, it's What the Doodle here, and in this session we're going to create a very simple web application using a dynamic language. Now, in the previous session, we had a look at dynamic language versus statically typed languages, and whilst my preference is always towards using statically typed languages where possible, I did mention that dynamic languages in terms of productivity on a very small project is very hard to beat. Now, I've decided to use a JavaScript runtime called Deno and using a specific web framework called Hono. Now we can have a look at that. So this is the Hono web application framework, and it's very nice in terms of user experience, and apparently it's ultra fast and lightweight, and has obviously a lot of batteries included into it as well, and apparently it can run on various different JavaScript runtimes, so for example Node, Bun, as well as Deno. So what I like about it is that it looks very simple, and it has that same kind of vibe, such as Sinatra, which is from Ruby, and yeah. So let's get cracking. I have been told actually that that the text can be quite small for those who are viewing this on a mobile device. So I'll try and make this as the actual font size as large as I can, so hopefully you guys can follow along. And all of this will actually be available on my GitHub, so you can actually have a look at the full code example for yourself if you want to. So the first thing we'll do is let's create a new directory. Let's call this. This is going to be the actual web application. Is going to be the classical to do. What I will try and do is obviously from the front. Well, obviously there'll be a front end part of it, and obviously a back end. The back end is just simple API. I'm not going to go in terms of attaching a full-on database, because for the purposes of this example that would be too complicated and too involved basically, but it would be trivial enough to extend it in order to do that. So what I'll do is just skip that part of it. Now, in terms of the front end, for this very simple example, you could technically use any front end technology that you want, but I'm going to do it in completely raw vanilla HTML and JavaScript. So we're going to avoid just completely everything, because that's really not the purpose. It's just kind of seeing how Deno and particular Hono works together. So yeah, so let's do this. Deno to do example. So let's go in there. So what we'll need to do is create a few files. Now I like to create the server file, so that's the server file. I'll run the backend part of the code. We need to make a public directory. So this will have this will host all of the static files. That's for the front end essentially. And we also need a deno.json file. So that's kind of like the manifest, or sort of like the project file, if you want to call it that. So let's have a look what we have. So we can see here we've got the public folder for all the static assets. We've got the deno.json and the server.js. Brilliant. So we can also go into the public folder, and what we'll do is we will create the index.html. So that's done. Now we can go back into the top level, or the root project, sorry, and we can now hopefully fire up our Visual Studio Code file. So what we'll do is we will close that out. Now, so as we can see, we have created our server file, which is for our backend code essentially, and deno.json, which will hold our sort of project kind of configuration, if that makes sense, and our public folder with the index, which is all the static stuff. So what we'll do is we'll create the tasks. And we'll create a run task, and essentially that will be Deno run. We can use the watch flag. We will need something like allow net. We'll probably need allow read as well. And we're going to do server.js. Now what this will do is that when we run it on the command line, when we actually boot up the server part of it, hopefully any file changes that we do, it will get reloaded by by the Deno runtime, so we don't have to constantly or manually have to sort of rerun Deno again. So if we now bring up the terminal, let's clear that. Okay, so we should be able to do Deno task or Deno task run. Fantastic. So it looks like it's now reading the actual server file, and it's the watcher process is just going to restart anytime there's any kind of changes. So the first thing that we need is a few part of the Hono dependencies, if you like. So we will do that now. So the first dependency that we need is Hono itself. So we're going to get that from. And one thing I do like about Deno is the fact that these are just 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 URLs essentially. So I believe it's something like this, and we also need. So we've got that. That's fine. And as you can see on save, okay, why didn't it like that? Maybe it's because it's like that. Yes, so that, yeah, it's capital H. Okay, that's fine. So we've imported Hono, and it's as simple as that. There is no, package managing and sort of build tools, any of that stuff. We can bypass all of that because it's just essentially URLs. You point it to a particular, file on the web somewhere. So we've got that. Now we need a middleware for actually hosting the static files, and again, this is can be found, I think, in the same, similar place, but it's deno.land/x/hono/middleware.ts. Okay, yes, have I done that correct? I have indeed. Okay, brilliant. So now we've got those. We've got Hono and we've got serve static. So the first thing that we're going to do is we're going to do const app is equal to Hono. Cool. Okay, so we've created our new application, Hono application, and we now just have to define the first, I guess the static route. So we can just do get and anything. So we can use a wildcard, and then we're going to say we're going to use serve static, and this takes an object, I believe, which you have to specify what the root is, and in our case that's the public folder. Okay, that's now done, and then we can do Deno serve. Deno serve, sorry, and it takes an object where we specify the port. In our case, I would like that to be 8080, and the actual app. Let's see if that works. Okay, so look, it looks like and that's really to get the actual static hosting to be done. So if we go into here, for example, and we just do something like a h1 tag that says hello world, my to-do app. Okay, so now if hop on back to our browser, and what we'll do is we'll go to localhost 8080, and there you go. So that's all working. That's we can get rid of that now actually. And what we'll do is we'll get the console tab up and running so that we can actually see any errors on the front end part of it. Now, of course, this is a terrible way of doing HTML, because obviously this is just the worst kind of HTML, but I'm just being super lazy here. Of course you would put the correct doc type and everything, but and even the body and everything, but I'm just skipping all of this. So we need to create our front end code, if you like, so JavaScript code, because we're just using vanilla stuff here, so hopefully we should be able to do text JavaScript. And what do we need to do? Okay, so we've got that's all fine. I can close that. We don't need that anymore. We've got our front end. This is our front end code, and this is essentially our back end code. What we will need to do is we will need to create a few API routes. So we'll call this API. So we need a few, well, before we do that, what we'll do is we will create a top level global variable. And this, you shouldn't be doing this, is a terrible way of doing it. But for this example, this is fine. So we're going to create a to-do list. So we've got a list, there's an array there. And essentially we need a few APIs. So this is literally all the API part of it. So we'll need one API to list essentially all of the to-dos. We'll need one to add the items or tasks into the to-do, and we'll need a way to delete it. So there's only three really. So let's start doing it. So we could do the first one. So let's define a path. So API / all. So this will be for this will be the API endpoint when we want to get all of the well, essentially all of the to do. Now we can just simply write a bit of console logging as well. So we can just say something like getting all the to do data, and then we can just return the to do essentially. Yeah. So once if you call all, then it'll get all of the data. So initially, of course, that'll be empty, and then what we would like to do is the delete as well as add. Obviously, those are the main aspects. Okay, so we need to add a route in order, or for the API to actually add a task. And actually, if you think about it, we need some way to track each of these tasks. So we probably need some form of ID, because then we can reference that, and we need that because then we can further on, we can delete that. So in order to do that, actually what we'll need is well, normally if you have a database, you would insert into the database, and that would generate you you'd have some sort of primary key that is automatically incrementing. In our case, we don't have that. So what we'll do instead is we'll just use a GUID. So a GUID is a uniquely identifiable, it's just a random sort of a hash like ID that is generated, and it's guaranteed to be essentially collision free. Well, to a certain degree. A certain reasonable degree, and it's a way of generating a very long, very unique ID that's completely uniquely identifiable. So we will get that from the standard library for Deno. So I believe that's deno.land. I think it's something like standard, something like 0.82, I think, / UID, and we want the mod.ts. Do we have that? Is it downloading it? Yes, so that's fine. Okay, so we've got the this is just part of the standard library. That's the GUID, version 4. There's I believe version 5 and whatnot, but version 4 is good enough for now. So let's actually create the post. So when we are adding an item, so this will be something like API add, and we need our asynchronous handler. So we're going to do that, and we can do something like we can log this to console and just say adding new task. Okay, so we will do something like the actual data is coming from okay, so we're going to get the data, essentially, the JSON data that's passed there, and then we're going to check if the data, I mean, we don't want to really add it if it's empty. But of course, if it's not empty, we want to add that to our global variable, which is our to-do here. And to do that, we need to first generate an ID. So we'll say, we'll create a new ID, const ID is equal to v4, I believe it's generate. And we could do something like, well, let's just add it. So we'll just say to do, and we're going to push, and the data we're going to push is the ID, and the task that we're going to push is the one that's passed from the front end. Okay, so we've done that, and we could probably console log this and just say add a new task with the ID of with that ID essentially, and then we can just return some JSON code. We could say something like action is okay. I mean, so that's fine. So now we've got so we can load all of the to-dos. We can add one, and we would want to also delete delete tasks as well. So we would like to add another API to essentially delete. So we can just say app.post. This will be something like API/remove. And again, it's going to be an asynchronous handler. We take the context, and then we can do something like, well, let's actually get the let's get the actual data from the handler, and then we can actually then say something like removing task, and then it's easy enough to remove, because we could just do to-do is equal to to-do dot filter. So where the ID is not equal to the data ID, and then we can just return a JSON response. So we can say, and let's see, yep, that seems to all run without any issues, so that's fine. So that's, in a nutshell, that is the entire backend, if you like, the web application completed. So we have essentially just three dependencies, one from the standard library, and two of those are part of Hono. So they're separated out. You've got the core, if you like, of Hono, and then you have a middleware for serving static content, which is your front end, for example. And yeah, that's handled here, serving the static. And then we have essentially created three API endpoints, one which is API all, one which is API add, and then one to remove. So now we can essentially move on to the front end. Okay, so we need some utility functions. So this is just in order to call the APIs. So two of the main ones really we need is doing a post, or HTTP post, and a HTTP get really. And so let's have a look. Actually, I just want to make sure the first one, which is, yeah, so the first one, get, that's a get call, and the other two for adding a task as well as removing a task are both posts. So we need to create these I guess helper or utility functions. They're pretty straightforward because we can use we can use the built-in standard web standard fetch to do that for us. So we'd obviously want the URL, we want some data, and we want some callback function that actually executes when we have the data that comes back. So we could say something like fetch. So we want the URL, oops, and a bunch of options. So the options would be method, in this case that is post, and we would want the headers, which in our case would be the content type, which I believe is application JSON. Okay, and then we would want the actual body of the text that we are sending across, and we can just stringify the data that gets passed in. Okay, so that's that. And then because this whole thing is asynchronous, we have to deal with we have to deal with the responses. So then we'll just say something like response is response.data, and then we can then apply essentially we can apply a function, and then we can also we need to sort of catch the error as well. So we can say something like I mean, we could probably just log it, to be honest. We could just log that. So we can just say okay, so that is our post done, and we could probably do something. But I mean, the get will be identical. Well, near identical anyway. We can copy that. So we can, as I mentioned, we've copied it, so we've pasted that now twice. So we just made essentially a copy of it. We can now go ahead and change that. We won't have a functional callback for that. So we probably don't need any of this. Get rid of this. Sorry, we don't need any data, I should say. We will then simply just call the function, because we're not passing in the get. We can't actually pass any data to it, because it's just a URL endpoint, which is obviously different to a post, because in a post we would have a data that we pass into the actual body when we make that call. So okay, so we've now, let me just clean that up a little bit. Okay, so we've got our get and our post method helper utility now done. And so now what we'd like to do is we would like to create another function. We'll call this load data, and essentially what we'll do is here, this will be the entry point where we essentially load data and then do stuff with that. So actually we can start adding in we can add just an element that we can, let's just call mount for now, because what we will do is all the data that we get back, we will want to build up some HTML and inject into, so we'll kind of render it into, so this is essentially a placeholder, a mounting point. And we can add also a text input to enter the actual tasks, and so that should be type to be text, and we can set the ID to task. And finally we need a button, so yeah, we will call this add, and then we also need a function to execute, so we'll say add task. Okay, so we can just say on click add task. So when that's clicked, essentially it will execute this function. So we could just test this just to make sure it's all working. So let's just do an alert that says to do add task. Okay, so if we look at hello world, if we refresh it, so as you can see, we've got hello world to do, and yes, to do add task. So this is working. That click handle is bound, and so let's go back. Okay, so we've got that add task. We want to load the data, and we want, actually what we'd like to do, add an event handler. So what we'd like to do is when the actual the page loads, we would actually like to load the data. And what we can do is the mount point, we could just say var mount is null initially, and what we then can do is just do mount is equal to document dot get element ID by ID, sorry, and we want to get the mount ID. So essentially what we're going to do is we have a global variable called mount, which is essentially for referencing this HTML element, and then we add an event listener. So when when the page is loaded, essentially we grab that mount point, and then obviously assign it to this variable here, and then we call our load data function, which will then go ahead and we can then call our API endpoint, which is to get all, and we need to pass a function that takes some data from the actual response that comes back. And what we'd like to then do, because this data should be JSON data that comes back, we can then, we've got the mount points. Yeah, so we've got the mount points. So we could just say something like let's HTML. So we're going to just start building up that HTML that comes back. So we can do data for each, because it'll be an array that comes back, and we can then say something like for each of those elements we can then do something like the following. So we can just say HTML, so we can say the x.id, so we could do x.id, so that's the ID of each of those, and then the actual task. So yeah, and then probably want a break line. Fine. So that will build that up, and then finally what we can do is we can then just say the mount point in a HTML is set to the HTML. So essentially what we're doing is when we call load data, we call the endpoint, and we get the data back. So this is just a callback function essentially, which will execute, and we get the JSON back. We iterate through it, essentially building up a HTML, essentially building up HTML, and then we mount that. So that's fine. And we would need to, okay, so what we'd like to do is we can say the task is equal to document.getElement by ID. We can get the task, so this is the actual input here. So we can get that, and then we just simply call the post, and it's going to be API add, and it's going to be a task which is equal to the task dot value, and then we need a function. We need a function that works on the response data that comes back. I mean, in our case, we're not going to really. I mean, normally you would the response that comes back would be things like errors, errors and validation. You'd handle that. In our case, we're just going to load the data. So yeah, so when we add a task, we call the add. Yeah, we call the add, and then we essentially reload the data. So when it loads, we load the data as well, and also we initialize it, I guess, the mount point, and set the variable up there. And also, so we haven't got the delete yet. So let's see if that works. It probably doesn't, but let's see how far this goes. If we load this up. Okay, so we've got a lot of errors, standard. Let's have a look. Let's expand this. Okay, so I've done a bit of debugging, and there was just some essential minor typos in terms of the path that we were calling, and for that reason it wasn't actually correctly, it wasn't correctly passing the correct endpoints. So those have been fixed now. So in fact, there's a little thing I wanted to clean up after it adds the data on the add task. What we'd like to do is we would like to set the value back to essentially to make the value null. So if we now have a look at our application, I'll make this a little bit bigger so you can see, and I'll reduce this down because I don't need to focus too much on that. So we can just say add some CSS as a task. If we add that, as we can see, and if that task has been added, so if we go back here, we can see those endpoints have been called. A new UID has been generated and it's been added to the data itself. So that's working perfectly fine. And of course we can add more. So we can say clean up code, and in fact if we refresh it, it should, yeah. So even when we reload the page, because that's held in memory on the server side, inside its memory, it calls it and it brings that back. So okay, now everything should be working. So of course we can reload, and it will pick up the it should pick up the data. Yeah, it's picked up the data that's actually running inside and held on the memory on the Deno side, on the server side. So now what would be good is to wire up essentially the ability to delete each of these items. So what we'll do is we'll just jump back, and on our index.html we will add a remove function. So we'll do remove task to be consistent. We're just going to take the ID, and then simply we can then do post, and it's going to be API/remove, and we're going to pass in the ID, which is the ID, and then we are going to respond with the actual callback. And here what we'll do is we'll just simply load the data. So that should be fine. So that's that. Now we need to tie that up, and what we'll do is we'll create a button. So let's have a look. Where we're doing the actual rendering, we will we'll create a button here. So button, and then let's well, we can do a self-closing tag. That's actually it would be nice to have an icon. So what we'll do, on click, and what we'll do that is remove task, and that is going to be the ID. And actually what we'll do is we'll get rid of this ID here. We don't really need that. That's fine. So okay, so we've created a button and we've got the on-click handler. We're passing down the ID in order to do that. And it would be nice to, let's have a look. It would be nice to get a little sort of a bin emoji icon. So if I do emoji trash, I think it's called, or bin, yeah, trash bin. Let's see what we can get. Just want a little icon that will look nice. Not that one. Let's have a look. Okay, let's copy that. Let's go here, and we want to paste that there. Okay, so I've got a little bin here icon that represents sort of trashing that particular task. So if we save that and let's reload that, does that work? Let's have a look. So if we reload it, yes, so we can see that there's two buttons now, and hopefully if we click on it, there you go, fantastic, it works, everything works. So we can add a new task and another one, and let's just check. If we do the exact same task, it should only delete one of them. So if I click on that one, yeah, it does work. So yeah, that's, so essentially, yeah, that's an entire that is an entire to-do application, a complete full-blown web server with a backend, a full-on API, and a front end all done. And you'll notice that there was obviously the way the front end was done essentially was just in pure vanilla JavaScript. So there was absolutely no no frameworks, certainly no libraries or anything like that at all. It was just raw JavaScript, and you don't really need a lot to actually create sort of fully. And this is a fully dynamic website, and yeah, it's just simple files. There literally are no build steps. There's no compilation or none of these complex toolings that you would generally have on these a lot more heavy frameworks. Now that's not to say that you cannot use them, because you absolutely can with this particular structure, because obviously you've got the public folder, which is where all of the static assets you would generally, I mean, if you did want to use a full fat framework such as React or Angular or Vue, then you would essentially this would be the dist folder or distribution folder, where after everything goes through a complex compilation process, it is emitted and placed here. And the actual Deno server with Hono, or this particular server code that's been done, is completely agnostic. It doesn't actually care in terms of what's on the public static files. It doesn't really care, and it will just host whatever is there, because we have that over here, where anything that's in the public folder is just hosted essentially, and it follows all the standard rules. For example, if after the / if nothing is requested, then it will look for an index.html file, and it will serve that. And obviously if you have subfolders and whatnot. So, and then obviously we have the API handlers for each of those get and post requests, and essentially we're sort of parsing JSON, parsing data structures, parsing them, and then we're creating JSON structures and sending that back. Now, of course, in this contrived example, we just held it in memory, so we had this var to do. Now, of course, in a real application, you'd have essentially a SQL database or something like that to persist that to disk. So, of course, if, for example, as you can see here, these are these tasks which are in memory at the moment. If I was to shut that down, and then if I rerun it again, and if we go back to our hello world app, and if we reload, none of that would exist, because it's been essentially nuked. So, I mean, for example, if I put nuked item or nuked task, for example, as you can see, if I reload it here, you'll see that it should it will reload back. Now, if however I go back, so this is the actual task ID here that was added, which is the nuke item. If I shut that server down, and then if I rerun the server again, and then if we head back to here, if I refresh it this time, you'll notice it's gone, because it's lost its memory. It's been, the actual process has been shut down, so therefore it's no longer there. Of course, as I said, in a more real world application, that would be the main difference in terms of where you persist that. You wouldn't persist it in memory, you'd essentially persist it to a database. But yeah, I just wanted to show how easy it is, and what I'll do is I will upload all of this code so that you can have a look on my GitHub account, and you can have a look and have a play with that. And I'll put a sort of a link or something in the video itself so you can see. So until next time, I'll see you on the next one.